Okay, in experiment E2, we have three parts. First part is half wave rectifier, second part is full wave rectifier circuits using bridge rectifiers, and third part is voltage stabilization with Zener Diodes. Let us see the first part, half wave rectifier. These are the objectives and the apparatus. You can refer your lab manual for the procedure. And here is the circuit diagram. Okay, experimental procedure. Now let us see the connections on the board.
Okay dear, how we start the connection is, here in this case we are using AC power supply. Okay, AC power supply, as you know, in the previous lecture we studied with the AC part. So here we are using 24 volt AC supply. Okay, one diode, one capacitor. This capacitor is variable. Okay, we can use a number of different capacitors. That's why it is shown in the dashed line. And this is a voltmeter where we measure the V RMS value, not peak to peak value. It is RMS value we will measure here. And this is the resistor, and this is CRO channel 1 and CRO channel 2. Okay, so let's proceed with the connection. This is the circuit diagram.
This is voltage power supply. Here we have 12 volts. We just put them in series to get 24 volts. And from this, according to the circuit diagram, from 24 volt we have to give connection to the diode, and from the diode, this is 24 volts, we give a connection from 24 volt to the diode, and the diode is connected to 3.3k ohm resistance, and it is grounded, the red part. Now first we give connection without any capacitor and check the output on the CRO. Let us connect.
So let us start with the CRO channel 1, okay? Channel 1 or channel 2, any value you can use. So we will see the input, what we are going to give to the CRO. So let us see, this is the CRO, and here, so let us take channel 2. So let's set the position, so it is, make it is 0, okay? Now we connect to the,
We are connecting channel 2.
now connect it to the common point and the supply point. You will get,
This channel.
so this is 24 volt AC supply, which you can see here. This is 24 volt peak to peak value, full wave. Okay, this is the full wave, 24 volt peak to peak. Okay, let us stop. If you want, you can just count it. Okay, if it is like, let me set the value properly. It is, sorry. So 1, 2, 3, 4, 5, 6, 7, 7.4 into 10. Okay, so this is your input supply.
74.
So let us check the output. This, you are seeing the output without the capacitor, okay, without the effect of capacitor. As you know, the capacitor, when we add the capacitor, then what happened to the input? You know it, right? So just let me reduce this up to the 10 volt properly. So set this. So what is this? This is half wave, positive half wave, and negative half part is clipped off. Why? Because there is a one diode here. There is a one diode here, where that means it is working in the only forward bias condition. When it is reverse bias, that means when there is a negative voltage, then it goes into the reverse bias, then your the negative voltage, negative part is clipped off. So this is half wave rectifier circuit. Okay, this is without the capacitor. Okay, when I add the capacitor to it, the effect will change. Okay, now you can draw, you can write your input. Okay, you can
74.
so you can connect this multimeter here, and you can find the value of 25.7 approximately. Okay, and so, and the output, let me check the output.
To check that using multimeter. 5 मिनट से पड़ेगा.
So there is no supply here. So let us check here. The voltage is around 11.4. Where input is 25.7 and output is 11.3. That means when you are giving a full voltage, approximately you are getting half. So that means the output is in the ratio of 1:2. That means when you are giving input value as 2, output will be 1. So it will be 1:2. Okay. So draw the output what you are getting there. So this is not the proper output. You have to draw this half wave here, or you can draw the full wave with the other pen and half wave with another pen. Okay. So this is the first part.
This is part 2 of experiment E2, bridge rectifier circuits. Here is the objective and the apparatus used. Theoretical diagram you can refer. And here you see the circuit diagram of bridge rectifier. Input is same 24 volts, and we are using 4 diodes. And first we will give connection without capacitor, as we have done in the previous part. Then afterwards we will connect the capacitor and then take the reading. Let us begin the connections now.
So when you see this point, so these two diodes are connected back to back. Okay, so we connect from here to here, and from here this point to this point. Okay, and so before connected to the supply, we'll connect the supply the same way that we have done in the previous step. Okay, so let me just clear this mess. Okay, so this is 24 again. Okay, so we short this becomes 24. From here to this point, we'll connect to this point here, and supply to this point. Okay, so let us short this too. So let us short this too again, and from this point we'll connect to the resistor. Okay, this is the complete circuit diagram without the capacitor. Okay,
Let us connect the CRO channel 2.
so this is the full wave. Okay, so again, if we check the input here, you can easily find the input as, yeah, it will be same. Just if you want to check again, you verify your input, you see the input here. Let us make it AC, so it becomes approximately 25 point or 26, whatever it is. Okay, 26. So just remove it and we'll connect to the CRO. So this is CRO. Input. Okay, this is the input supply. So here you have to draw the full wave. Okay, this is the full wave you have to draw here. So what is input here? What we have seen here, it was 26 around something. Okay, so output, so just I will remove this and I will connect this multimeter. Okay, so output is 10.7 or 11 you can write. So this is bridge rectifier. This is without capacitor. So now, so how it will be? So this is the full wave, okay? This is full wave. When it is full wave, so that means this is positive side and this is the negative side. Where in the half wave rectifier, the negative part was clipped off completely. That means we will have a loss of information over there. So again, so let us remove this and connect it here. So if I connect to the output, so here you can see the negative part becomes positive here, right? In the previous stage it was positive and negative was clipped off completely. Now in this case the negative part is just like clockwise rotated, okay? So this becomes the full wave rectifier output. So draw here the full wave like this, okay? So what is the ratio of input and output here? Sorry, so output is previously I put on AC, so approximately the input was 26 and output is 22.3 approximately, okay? So it is same approximately, okay? That means it is 1:1. There is no loss of information, okay? In this previous case there was 26 half, here 26 approximately 26. So it is 1:1. When you are giving one input, you are getting one output without loss of information. So this is the full wave you can draw here. That's it. Now we'll connect the capacitor same way. So if I connect 0.47, so let me connect the wires, small wires. So now you can see here, this is becoming exponentially, okay? Here it is charging. When it is negative, it is coming like exponential, okay? Not it is like not straight or a small curve, okay? It is exponential. So let us add 10 micro to it, and the output is same way. You can write input is the same, 26, 26, 26, and output it is 23.1. Again, when you connect to the 10 micro, the output will be 32.5, and just run it. So it's becoming more like a DC, okay? So again, if I add so it is 4.7 micro, not 47, okay? So you can write 4.7 here. So just check, it is not with the 10 micro you are getting approximately DC, okay? Because 10 micro is more or less value, so 4.7 is more greater. 4.7 micro, make correction, it is 4.7 and it is 30.6, okay? This is the bridge rectifier of full wave rectifier.
This is the third part of experiment E2, voltage stabilization with Zener Diodes. This is the objective and the apparatus required. Let us see the connections now.
Here we are using power supply 0 to 12 volt DC, not AC, okay? We will use here the DC part. As you know, DC part, it is simple. Many times you have done it. So it is from 12 to 100, okay? From 100 to the Zener diode, okay? Zener diode what we are using now is 8.2, ZD 8.2, okay? Okay, from here we'll connect to the ground. This is a simple circuit, that's it. So here we are going to measure the input voltage in this. And we use other voltmeter to measure the output.
एक में रहना दो दो
Simultaneously we have to include it. So from this point to this point is the voltmeter. Okay.
एक मिनट कनेक्शन से
So make the input voltage 5. So when you increase the voltage 5, the output voltage is 5. So let me just check this. It is 5. Okay. So it is 5. Increase to the 6. To 6. Make it 7. It is 7. Make it 8. It is 8. Make it 9.
ये बताओ
Make it 9.
पूरा 9 10 11 ले लो फिर एकदम मिलते हैं
So it is 8.1. For 10 it is 8.2. For 11 it is. So as you can notice here, after a certain value the voltage is stabilized. So voltage will not increase when you increase the input voltage. So the maximum value here is 12 volt. So it is 8.3 only. Approximately from after the value 8 volts, it is increasing from 5 to 8. It is increasing. Okay. After 8, if you increase the voltage, input voltage, it is constant.
Now let us start for Zener Diode 6.2 without load. Here is the Zener Diode of 6.2. We just replace, instead of 8.2, let us use 6.2. Now let us see the readings. Let us begin with 3 volts. It is given as 3. Now according to the table, just we increase it to 4. The value is 4. Then V in is 5, V out is also 5. Then we make it 6, it is also 6. Now from here, even we increase the value of voltage in the input, the output stabilizes. It doesn't exceed more than 6.2, 3 here in this case. Similarly, we make it 10. Still you will see that the value here is 6.3 only. Now let us document these values here. For input 3, output is 3. For 4, 4. Up to 6, it is 6. When it is increasing more than the value of 6.2, we see that the voltage is stabilizes to 6.2 only.
So for this case, you need to connect the supply voltage to the 12 volt fixed supply. Okay, and add the load 2 volt, 2 kilo ohm, 1 kilo ohm, 0.5 kilo ohm, 0.2, 0.1, 0.5 we